Now recording. Okay, today is the 22nd of March, 2019. Broke a fingernail. And let's see, this is the regularly scheduled class meeting of ITSE 2309, coming at you live and direct from our studio in beautiful downtown Plano, the best place in the United States to live, or so I'm told. Okay, let me see if I can get to what I was doing here. People are asking me about the possibility of having an Oracle class. And right now, we do not have an Oracle class. The ITSE Oracle class is very similar to in the college curricula. They do not like having classes, or in this rubric anyway, this ITSE rubric, they typically don't have classes that are about a specific software. So for example, if you look at what is ITSE 2309, it doesn't say it's about SQL Server or Oracle or something like that. It's just SQL. And so that's the way I'm supposed to couch this class, is just as pure SQL, not teaching specifically any more than I have to anyway, SQL Server. I don't mind doing some of it, but it's not really about that. It's about SQL. So everything I am teaching here really should go to all of it. Now, if you're interested in a Oracle or an SQL workforce class that is aimed at sitting perhaps for the Oracle certification, the first level of Oracle certification, you need to talk to these two people right here, and I've put their emails up here, and I'll post this this guy. So first one is Ann Cervantes, and she's the department chair, and our big shot dean, Michael Kaufman. They're the ones that would do that. Now, I'd probably get on board and push with it, but since I'm retired, they don't listen much to me. Okay. Okay, I'm going to start something new, and it's going to go like this. Down under in the modules, at the very last module.
Hey, Dr. Smith, I'm sorry if you can hear me.
Yeah.
We can't hear you online.
Okay, are we?
Let's check again.
Okay, voice check.
I hear it.
Okay.
Yeah, I can hear and see video.
Can you?
That one turns volume low.
I don't think my volume affects how much I'm. Okay, let's see, who is this? Who's that speaking, Brad? Daniel?
Daniel can hear and see video fine.
Okay, Brad, was that you that said you couldn't hear? I mean, kind of a silly thing to ask.
Try typing who can see or hear
Uh-huh.
on the notepad.
Well, oh, it's from Brad.
Check see if it's up.
Okay, if one person is hearing me, and I have a monitor here in class, so if one person is hearing me, everybody should be, as far as the TCP/IP connection goes. Now you might.
Oh, I do know what the issue is.
What's the issue, Mr. Brock?
Let's see if I can find it.
Okay, you can hear now.
Volume mixer. Click check volume mixer.
Well, I don't think if you're hearing me, then and one person isn't, that it shouldn't be.
This picture right here that's caused the entire issue. The volume mixer.
No, your speaker shouldn't cause the issue
No, I
to.
meant on his end.
Oh, okay. Well, I don't know. I can't troubleshoot that one. Okay. Headset problem. Okay, I see it. I'll close the chat. All right. Now down at the very bottom. Let's see, we have recorded lectures, and I've changed them a little bit. So I haven't published this one yet, but I have it down here as lectures 3/22/2019, which will be published once I put the setting in there. And notice that this one has changed a different icon here. This is a quiz. And in the quiz, when you go to it, let's see, you're going to see something like this. So this is the instructions. During lecture, I gave you the answer to the question. View the recording and answer the question. The YouTube video will be here. You will have only one attempt. It says, and the quiz locks. I'm not going to lock it, I don't think. And then the question is, according to the lecture from 3/22, what is your instructor's favorite color? And so at some point during the lecture today, you'll hear what my favorite color is, and if I don't, you can ask me the question. You guys that are here will write it down, because you will also go take the quiz and you'll get your point. So I will tell you at some point during lecture, and the idea is people aren't viewing the lectures. I can tell that from the questions and from the people that don't know when the test is or stuff like that, and so people aren't viewing it. So at least this way, I'll know whether you saw the lecture, at least enough of it to get my favorite color. Okay, so it's going to be a one attempt thing. I'll need to troubleshoot this. So if it doesn't work the first time, we won't get our knickers in a big knot. I don't want to lock you out of the lecture, out of the quiz recording. I don't want that to lock up. So I don't know how I'm going to do it. I'll work with it. But so go to student view. And let's see, so you go, so if I'm a student, I'd come into modules. This is what it looks like to you. Go all the way to the bottom. And, no, that's the wrong one. Oops, I haven't published it yet, so it's not visible in student view. Anyway, I'll work with that, and right now I've just got it as like 1 point. I mean, I'm not going to worry about it until I get it running out. Next semester, I'm going to start it from Jump Street, embedding the guys into a quiz, embedding those lecture notes in a quiz instead of just being there. Okay, see, we have finished the test one. Test one, I just got it finished getting it graded yesterday, and I was fairly happy with them. I had quite a few real high grades, and not very many poor grades. Very few. So in general, when I get that, I'm pretty happy with it. Couple of things. Well, people are still writing left join, right join, and just plain join. Now, what's wrong with that? Well, nothing, but that's not the way I'm teaching it in this particular class. So this is a class on SQL. And if you're pure SQL, you will always write left outer join and not just left join. The reason for this is not all platforms will accept left join. Oracle will, SQL Server will, but that's not SQL if you write left join. You're truncating the syntax. And it's fine. If you know that you're writing for an Oracle platform or an SQL Server platform and you want to do that, do it. It's your business. But in a class on pure SQL, we will write. Well, right, inner join, left outer join, or right outer join. Another point is that we typically don't use full outer join very much at all. I can use a full outer join, and I can use a full outer join, and then I don't have to worry about left and right outer join. The thing of it is that it makes the query twice as expensive if you do the full outer join, because a full outer join is a union. Remember, a union takes two and puts them together. So it's a left join, union, a right join. And then you just throw away half of it. So it adds a lot of cost to the runtime. Okay. So we won't, I haven't even really mentioned full outer join. There are very few problems that need it. I can usually write an outer join problem in terms of a full outer join, and then down in the where clause, I just throw away half of it. Yeah, but there's no point in doing the full outer join if you don't. So none of the questions in the exercises call for a full outer join. What else? The databases, are using our databases. When I come up to the assignments, I know what the number of rows that will be returned on my data. On my data. They don't have to, whether yours returns 54 rows or not is irrelevant. When it hits mine, it's going to return 54 rows if it's correct. What you do with your data is your business. Now you can refresh it. In other words, run that SQL create script again. And we'll need to do that when we get to the dates and times, because we need to have our times current. So I run it, and if you have if your database is named differently than mine, we have a problem, because it's not going to run, and I have to stop and say, hey, your database is misnamed. We have two databases that we, okay. One of them you might remember was the Scratch database. Scratch database, think scratch paper. Scratch paper. Anything you want to do, I do it there. I just create stuff, throw it away. It's a throwaway database. So if I want to create a table named pets, I create a table named pets. If I want to go in and delete all the tables, I just go delete them all. It's just, I can create anything I want to there, and I don't clutter up my working database. The one that we're going to use is AP_DB, that is accounts payable _DB. And this one is simulating our working database. Now, you can change it. If you want to change the data that are in that database, you go right ahead and change it, because it is yours. But we should kind of keep it fairly pristine. And if you really trash it, go in there and run your code again. Run that create AP SQL, and it'll bring everything back, put it all back. Okay, questions? And so I'm going to get fussier about that, and I'm going to get fussy about using the idea of inner join, okay, because you can't just say join. And if those of you who choose to take my advanced class, I think it'll be offered next semester, or in the fall at least. Yeah, fine. You just say join, and I let you shorten the syntax. You can drop the as also, and some people will. But you have to know that you're writing for an SQL server before you can do that. And technically, we don't know that we're an SQL server. Okay. What are we talking about now? We are talking about subqueries. So we are in Module 8. We're talking about the subqueries. see if I can, okay. The simplest one, most of the table joins that I have can be done with a subquery. It is particularly true when everything that is being output from that table join comes from one table. So in this case, everything, let's see, everything comes from a single table. That is meat for a subquery. So I will tend to think of a subquery. Let's see, what are we doing here? This is an outer join. So I'm finding, so what is this? This is a childless parent query. So I look at the outer join. Which way does it point? Left outer join. It points to the parent table. I know that vendors is the parent of invoices. So the left outer join says it's pointing at the parent table, the vendors. So I'm finding childless parents. If it were a right outer join, then I would be setting it up to find invalid children. Okay, I couldn't select vendor name. Well, I would need to select the invoice ID because I'm looking for an invalid invoice ID. So if I have this pointing right, I'm looking at invoices and trying to find unmatched records in there. Very seldom will you ever get unmatched records from both of them. I don't think I've ever written a query, well, okay, one, in my whole 30 years doing SQL. On doesn't change much. Where invoice, where the child is null. So I'm trying to find parents that don't have children. I have to look at the parent table where the child is null. It's pretty straightforward when you think about it. People have trouble with outer join. It's not that much trouble. How about how would I set that up if I wanted to find orphans? A child with no parent. It's a trick question. I don't have to do a join to find orphans. Orphan, I can tell an orphan record is a record with a null foreign key. Okay. So sometimes I might give you a problem. I'll go over it again if I do. Find all the orphans in here. Find all the orphan records, the records where there is no parent. It's null. It's different from an invalid parent. To find an invalid parent, I have to have both the child and the parent table in there. But just to find orphans, I can find an orphan because they don't have a parent. I can just look at one table. Okay, and in this particular query, everything returns come from one. So this outer join I can write very easily as a subquery, and I probably would. If I can get that on the tab. I would probably write this as the subquery, subquery instead of the outer join. Okay. So I have a query within a query, and so select vendor name from vendors where vendor ID not in this query. To me, that is very intuitive. I tend to think so where the vendor ID is not in. So these are the ones I have. This makes way more sense than a join. I personally think so. I was a person in the class commenting that this makes more sense than a table join. I think it does. In fact, I think if I were writing the text, I would probably start with the subquery. I don't know whether I'd start with the subquery or not. They both, you need them both. And many times you can select either one. Some things, when you are selecting something from vendors and from invoices, it gets a little more difficult to write it as a subquery. When you are selecting, finding the maximum value, and you want to get all of the ties in there, it's very difficult to write that as a join. It can be done, it's just, why? So I look at it like this: if everything I need is selected from one single table, I'm thinking subquery right there. But I could do it as a join just as easily. Observation: syntax requires the parentheses. And when you write the parentheses, I'm going to get a little bit fussier about format. And I see some strange formats developing. You're an artistic group of formatters. I tend to allow you to experiment a little bit. What I do like to see, I like to see parentheses. When the parentheses is opened, I like to see the parentheses close immediately below it. I like to see everything inside of here indented one tab for each set of parentheses. This is true in most programming languages. This is just a way of formatting code that tends to carry through to C and to Java and to not so much Visual Basic formats itself, but which is why I don't like it. One of the reasons. Some people believe that a subquery is more intuitive than could be an inner join also. But in fact, in general, a subquery is the same thing. Do not use the distinct keyword in the subquery. When you are using in or not in, do not select distinct, because the system cannot tell whether you really need the distinct or not. It doesn't matter whether it's distinct or not, because it's either in the set or it's not in the set. And there's no point in asking the system to go down through there and get and eliminate duplicates. We don't care. So don't use that. It'll make the query less efficient. Let's see. And this is by way of review. Come on. Well, are we going to get through this today? I don't know why it's being so recalcitrant. Let's see, SQ subqueries. Okay, this is the one that I really love a subquery for. This is finding the maximum invoice total from invoices. Notice that both of these subqueries in this guy are coming from both of the queries are on invoices, and that's fine. This turns into a table join, by the way. A table is joined with itself, and I could do that with a table join. To me, joining a table with itself to get this is kind of a pain in the neck. So this one is meat for the subquery. I want to find the maximum of the invoice total, and maybe could be perhaps that there are multiple ties for the maximum. Okay, so go ahead, please. How heavy?
Heavy, because you are holding the table, getting the first time, and you hold it again when it's already hold. How heavy it becomes?
I think you're asking about its computational complexity. The runtime support system of SQL can do anything with it that it wants to do as long as it gets you the correct answer. In programming for SQL, you very seldom will ever tell it how to do it. Does it have to do this? Does it set up a loop here and stream the other loop across it? Does it put them both in memory and merge them? The system takes care of that. SQL is an artificial intelligence language because we will almost never have a loop in our program. I mean, we can look at that and say it has to have a loop in it, and we know that, but we won't write it. We let the system decide how it's going to do it. So the system is free to take our query and change it into something completely different any way it wants to do it. Now, there's a few things that we can do to help. For example, don't put a distinct keyword in the subquery. But as far as that, if it's just a query subquery, it's free to take it and turn it into a join. Or you can take a join and turn it into a subquery, as long as it gets the same answer. When you specify, when you're programming in SQL, what you're doing is you're specifying the answer. And then you let the system take off and program itself to how it gets there. So you're saying, I want the answer to look like this. And then the system goes. Okay. Minimum also. Another one that I use a lot, I didn't, is average. So what if I had average? So I want to find everybody who is exactly average. Well, me, I'm just like everybody else. Remember that that joke from one of the Monty Python movies that had the crowd was chanting and the preacher was saying, "You're not just like you are not the same as everyone else." And the crowd would say, "We are not the same as everyone else." And this one lonely voice says, "Well, I'm the same as everyone else." The fact of the matter is, there won't be many that are average. So if I said, where they equal the average, they won't be average. So I might say, are they within 10% of average? Okay, and a subquery will work for that. I have to say between, but okay, so here everything is coming from one table. Now, what if I wanted the invoice total also? So here I say, okay, I want to see the invoice total. In other words, it's not good enough just to see that I want to see what that maximum total is. So why won't this work? I'm going to get an error message here. And I have it here. And here, for my reading pleasure, I receive an error message and I say, why? Why? Dave, do you see why?
I think you got aggregate function.
Yeah, you're right. Juana, is that what you're saying?
No.
What's the problem?
I think invoice total is coming from invoice.
It's coming from invoices. There's invoices. Let me point with my mouse so people out there in internet land can see it. There's invoices. This comes from invoices. What's the problem?
That right there.
It's an aggregate function, and I have in the same line something that's not an aggregate function. So what do I have to have? A group by. New rule. Okay. So if I want to put this in, I have to have the group by. So if I add in the group by, it will work. Okay. What if I wanted the vendor name? That's a good question. There's a good test question. Ooh. What table is the vendor name in? By the way, we've been typically using 2 or 3 tables. We're going to start using more tables as we go. So right now, we've got vendors and invoices mainly, and then some others. So I want the vendor name. What table does that come from? I don't have vendors in this query. Right. So the vendors, if I wanted the vendor name, now I really don't have a choice. I can still okay, here it gives me this one will give me the vendor ID and the total. And the max is 37,900. If I had had others in there that tied it, they would also have shown up. And if I want the vendor name, what's that? Inner join. Vendors. Let's see, invoices. Now later you'll be able to drop the as, so you just say invoices I. Lots of people will do that. It doesn't work everywhere. On I vendor ID equals V. And some people will, let's see, so what's the problem here? Why is it giving me this squiggly line under vendor ID on line 11? Right, which vendor ID is in both of those tables, so I have to decide which one. It doesn't make any difference really. I'm going to use the one to which it is a primary key, as I typically do. The other thing that you'll see, I usually will put the parent table first on the left, but I didn't, so get over it. So now this one, now I can select and this guy, when I'm scrolling off, I'll typically break the line. I don't worry a whole lot about making these guys line up. Some people will worry more about that than I do. Main reason, yeah, let's see, group by, I need to specify here. Doesn't matter. Well, I probably should keep them the same. So when I run this, I'm going to see what's the matter. Oh, okay. And I also need to group by vendor name. Because the vendor name, we've triggered the new rule on that one also. Didn't mean to save. So now it should run. So I had to have this inner join in there. I really can't get that one from a subquery. I can, but I can't get it from this kind of a subquery. Okay, so you'll notice some things about this kind of a subquery. I call it a trailing subquery. I've never seen that used in a book, but I call it trailing because the query, the subquery, happens in the where clause. To me, that is the most intuitive kind of a subquery when it comes in the where clause. So inner join, outer join, the subquery comes in the where clause. Usually that is the case. Okay. I don't know how much we've covered. This was mentioned in the textbook. This one comes from the, go next. I don't know why this thing hangs. I think there's something wrong with my browser. Yep.
I think it's the magnifying glass on the top right of the URL bar.
Top right.
Yeah, the magnifying glass. I think if you click on it and reset, it should fix it.
Okay. Oh, well, we'll give that a try. I'll see if that works. Subqueries. Talked about in versus equal. That when we were in one of these guys and we were using this term in, that the equality sign will also work there, but that gives me a problem logically. Why do I have a problem? Because they're not talking about equals. They're not the same thing on both sides of the equality. Therefore, I do not like equal there. I want to see in. It's either in the set or it's not in the set. With respect to greater than and less than, I like to see greater than all, greater than everything that's in that set. The other option is greater than or less than any. It means it's greater than the smallest thing in the set. Or if you say less than any, it is less than the largest thing in the set. I usually use all. Okay. Let's see if I can get to this one. Okay, now the fun begins. Find the vendor ID with the greatest invoice total. That's what we've been working with here. Variation on the question is find the vendor ID with the greatest invoice total. But I'm going to change that question just a little bit. And I'm going to say now I want each vendor ID along with the greatest invoice total for that particular vendor. Okay, now you're talking about a more difficult computational thing. Now you're talking about a nested loop. We got to hold this one and run it, then hold the next one and run the query. So this is, we got a nested loop going on. This one's going to be more expensive to run. And we'd like to avoid running things like this. But if you're on a test and I tell you to, you can't, huh? Okay, let's take a look at it. I can accomplish this with a self join. And this is a table joined to itself. And this is discussed in the chapter of the textbook where it's talking about table joins. And notice this one, I call it I1 from invoices as I1. So I'm taking invoices and I have to rename it. Inner join invoices as I2. So I'm joining a table with itself. So what am I doing? If invoices has 3 rows in it, how many rows does the resulting join have? It has 9. On I1.vendor ID, I2.vendor ID. Now I'm down to 3 rows each, 3 rows in the table. But let's see, I'm taking the max here. So the max, and I have to group by the vendor ID. I think I have this one up over here. Okay, here it is in this one. So the trick to this one is the table is joined to itself. And we saw this when we had let's see, employees. And an employee has a supervisor. Well, the supervisor is also an employee. Now I want a list of each employee, and their supervisor. I'm gonna get duplicate supervisors. That would take a self-join. And so here I get 34 rows. So this must tell me that if I have the greatest invoice total, this must tell me that I have 34 vendors out of all that lot that have invoices, at least one invoice. Because well, if I've only got one invoice, that's the greatest one. If I've got more than one invoice, am I still recording?
Yep.
Okay. If I've got more than one invoice, well, it'll take the greatest one of those. I don't remember. Okay. And anyway, this is doing it with an inner join. Now, why did I have this in here? Notice that the invoice table is joined with itself. The best way to understand a correlated subquery, as I wrote here, is let's look at one first that is not a correlated subquery. This is not a correlated subquery. This one is just a plain old subquery that's going to give me the vendor ID and the invoice total. So this, we're going back to where we were a few minutes ago. This is just find the vendor ID that maximizes the invoice total. And if I have ties, if I have 100 that do it, I'm going to get 100 in the answer. I don't know how many I'm going to have. I think I have to have at least one. Well, what if I had an empty set? I can't take the max of nothing. So I would get an error there. If I didn't have any invoices, I can't take the max of something I don't have. Okay. And notice we have invoices and we have invoices. Now, I've got invoices appearing here twice, the table. All right, now let's go to a correlated subquery. And here I have invoices and I have invoices, but the difference between a correlated subqueries are expensive. Before you get out of here, there will be one correlated subquery question somewhere. Notice that this one is named. I named it INV outside. That's just a name I made up. Some people call them I1 and I2. I call it outside. And I call this one inside. Okay. So select invoice total, my max from invoices, where invoice total in. So we're still in that trailing subquery. Subquery still coming in the where clause, but look how it's different here. As invoice inside, and where it gets different, get that all on the board. Okay, where it gets different is right here in this where line. Now, in the where line of that inner query, I reference both the outer table and the inner table. They're the same table, but I'm referencing them by different names. From the inside query, this is true generally speaking in computer science. From an inside query, I can look outside and I can see this name. From inside, I can see this outside name. From the outside, I cannot look inside and see the name. That's true in Java, that's true in C. Anytime you can look out, but you can't look in. Called scoping. So I'm selecting the max from outside where the two vendor IDs are equal. So I'm going to find all my vendor IDs from vendor ID number 110. I'll go through all of those guys where they're equal. I'm going to go through all of those guys, and I'm going to find the max. And then I'm going to select that invoice total, print that. Now, if I have, I won't get any ties on this one, right? Because it's just a vendor ID. So if the maximum for a vendor ID is 36,522, that's the answer for that vendor ID. I'm not going to get ties. So when I run this guy, if I look at this answer, I get 34 rows, and the max, the top one, vendor ID 110, has a maximum of 37,966.19. We'll use that as a check. So when I come over here and run this one, I get the same number of rows, and at least the first two are the same. They're all the same. They are the same query. Which one is better? Well, depends. Which one do you think is more intuitive? Students usually have trouble with joining a table with itself, which is what a correlated subquery is doing. It's joining the table with itself. I don't know on this one which one I would say is the most intuitive. But the trick is that you have the same table with different names, okay, in both of them. So in the self join, I have invoices, and I'm calling it I1 up here. Inner join invoices, I'm calling it I2 there. So I'm joining the table with itself, where the vendor IDs are the same. Find the max. Down here, I have invoices. I could have called it I1. Here I could have called it I2, where the vendor IDs are the same. Questions? Dr. King has a pretty good video on that. I do want you to answer that video. Let's see, by the way, I guess I should give you my favorite color today. My favorite color is red. My favorite color is red. You might want to make a note of that. And that's the answer to the quiz question. And let's see. I think we'll probably go ahead and take a break now, because I want to go into another kind of a subquery. And then we'll wrap up. Subqueries, typically I take 2 weeks on subqueries. Let's do. And then let's see, after we do the subqueries, what do we have? Okay, let's find out if we can do next now. Hey, look, it worked. You were right.
Might want to, well, we can't do anything with Google Chrome. Then you get that glitch fixed.
Yeah, well, I like Google Chrome better. Data manipulation, I think we're going to skip over chapter 9. Data types will be our next one. And so chapter 10, I don't think I'm going to go into that today. We'll finish up today with derived tables. And for right now, I'm going to say let's take our short break. When I come back, you're going to ask me, have I turned the recording back on? Recording is paused. And resuming recording.
And it says recording.
What?
It says recording on monitor over here. This one.
Recording.
The others could tell if it's recording, if they have it on full screen.
So it shows that it tells you that I'm recording?
Yeah.
Or are you recording it over there?
No, this one's not recording. The record button here is not there. But it says it's recording right here.
Mm-hmm. Okay, so that popped up when I turned it on?
Yeah.
Okay.
but that won't be led. This one's recording.
Mhm. Looks
I
like,
can hit
go,
it.
go ahead and hit it and see what happens. Please request recording permission. Oh, you have my permission. Okay, I'll, if you guys want to record it, I will.
Okay.
Um,
Well, it's not in the session. it's just
nah, we don't want to do that right here. Okay, up until now, all of our subqueries have come in the where clause of the query. They can come other places, and specifically, a subquery may appear in the from clause. So if you think about this, it is fairly intuitive that it would be thus when you think, what is a subquery? Excuse me, what is an SQL query? An SQL query is a table. It's a table that exists just for a second. In fact, we're going to see that I can save a query as in the database, and the query will act just like a table. It won't have any data in it, but I can make a query and I can save it and I can just use it as I would use a query. And the person that is sitting there writing SQL that uses that won't even know the difference whether it's a query or we call that a view, a database view. It's a little bit like in Access. When you write a query in Access and it asks, do you want to save the query? Okay, that's not really a query, that's a view, but I'm not going to argue with them or whatever. Let's see. I think I have this one set up here. I think I'll bring this on down here. Practice what I preach. And okay, I want to select some things. I want to select the vendor ID. Okay, let's see, what do I want? I want the vendor name and my max. This style of writing a subquery, let me go in a little bit more. It is considered wrong in database to return more information than is explicitly needed. It is considered an error to return more information than the question on the test or whatever asks for. So if I say to return the vendor name and the vendor ID, and you return the vendor city also, that would be considered logically an error because you gave me more information. You exposed information that might be, we assume everything's confidential. So confidentiality is a really big issue in database. This is why the database administrator is a very highly placed person in an organization, because they have that organization's crown jewels, which is usually the database. The most valuable thing Collin College possesses is its student database. What do you think that would be worth on the market? All of those social security numbers. Is there any other kind of a black? A student says, on the black market, do you mean? I said, well, it's about the only place you sell a social security number, I guess. Somebody else points out that it's done wholesale. Yep, that's true. The merrier, huh? But I'm just pointing out that a database in general will have confidential information in it. Now, this type of a query is generally used to protect confidential information. For example, I want the vendor name and the maximum, what is it? The maximum payment total for that vendor name. Okay? Now, I'm not allowed to expose the vendor ID. Okay, so a vendor name and the maximum total, but we cannot allow the vendor ID to be part of it. So the vendor ID, I'm going to have the vendor ID in there to group by. I don't know whether I have to on this one or not, but do I have to here? Vendor ID. I think I have to have the vendor ID in there to group by it. Okay. But yeah, yes, I do. I think I'm going to get an error if I don't have the vendor ID in the select line because I want to group by it. But I can't show you the vendor ID. That's the social security number or something like that I'm not allowed to show. I can't have it as part of the output. So this is going up to a web page. This information up there, your name and the amount of the payment, the amount of whatever it is generic. It's an aggregated thing. It says, you know, this is how much. It's something that if I put it together and I say, you know, students at Collin College paid this much money in tuition, and all you can see is how much money everybody together paid. I have no idea how much you contributed to this. Then I wouldn't be violating confidentiality. Once I expose your credit card, your social security number, it's a big deal. Now, this kind of a query is generally used, that the one common use for it is to hide information. Because I could get this if I didn't mind having the vendor ID come out. Well, there's no reason I could just simply, I'm this one. All the information's there. It just has this extra piece in it. And I'll commonly use this, what we call a derived table. It's a subquery that is in the from line. So it's a subquery that's acting as a table. Notice some things about it. Let me point with my mouse again. If I start pointing with my finger, you're supposed to tell me that you guys out there in internet land can't see it. Okay. From the parentheses are required. Okay. One other thing that's required. You must name it. What will happen if you forget to name it?
An error.
I get red squiggly lines, which means I'm probably going to get an error. And I think I get some kind of a pretty weird error because I've forgotten a couple of them. I get incorrect syntax near the end of it. So it says incorrect syntax near this. And well, if you didn't have it, you're sitting here looking at this going, you know, what's the problem? What's the problem? Well, the problem is we didn't name it, so we have to give it a name. I usually put a space. Don't have to. I usually name it on that line. So I will usually drop down, put my, if you need to be a little fussy about these parentheses. So where the parentheses opens, it should close right below it. Notice that inside of this one, I have an inner join. I don't want to reveal anything from the vendors table, the invoices table. Oh, except this aggregate. Okay, so when I run this, I'm only going to see what I'm allowed to see. And even if I were to select from this table, as long as I keep that SQL and only pass the result up the chain, this will be secure. Now, there is another way I can do this, and I don't know whether I should talk about this right now or not. I'm going to talk about okay, I will, and then we'll come back to it later. And now for something completely different. Must have a go. Must have a go. Create view. Okay, this is coming up later. We are going to talk about this later. So I'm stepping ahead, but only by a little ways. Heck, we're halfway through the semester. Create view. What's the view's name? What's the view's name? D. Okay, create view. Named. Yes, you can ask me a question.
So that works like the subroutine, a subroutine. The old people programmers subroutine.
Ask me that again, Juana. I didn't quite catch it.
Okay. In what you are writing right now.
What I'm writing right now is creating a view. If you're going to ask me what I'm writing right now, let me finish, and then you can ask me. Okay. Create view. Give it a D. That's the name. I could have called it Teetotally Humswoggled. This as is not optional. Parentheses. And I usually put them both. Copy. Paste. Okay. I created something. What have I created? I'm saving this query in the database. If we were in Access, this would be called a query and I'd be saving it. So I'm saving the query. I'm not saving the data. I'm saving the query. What is a query? Query is a table. Okay. And notice I have go. When you create anything, when you see that word create, the statement should have a go before it, unless it's the first thing in the file, and a go after it, unless it's the last thing in the file. Okay. Just put a go before it, a go after it. So when you create a table, create table, go, create table, blah, 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 go. Okay. If sometimes it'll let you get away with it on tables. Will not let you get away with it on a view. A view, you have to have a go. I'm getting a little bit ahead of us, but I'm creating a view. So this thing that is D is acting as a table. Well, gee, that's what it's doing up here. So I'm creating it as a table right here dynamically, and it's acting as a table in the view. Excuse me, in this query. Paste from what? D. Okay, I'm going to create the view now. Execute. Success. Notice it didn't run it, it just created the view. If I try to create the view again, I get an error. Just like creating a table, what should I have up there? If object ID D is not null, drop view D. Okay, that's my creation script. So I'll create my tables, and then I'll create the views that I need. Sometimes I want it as a table, sometimes I want it as a view. Well, let's see what happens. Do you think this will run? Do you think I can say select vendor name MyMax from D? I believe I can. And I get exactly the same thing. These are exactly the same. These two statements here, these two taken together, are the same as this. Now, I don't know, I don't think it's going to give me a problem with this name right here, because I think that the name will be hidden inside of there, and I don't expect it to be a problem. That gets to be a kind of a tricky question. When do they conflict with each other? And those of you who take the advanced class are going to find out that you have so many different levels of names. You have names down in a program, you have names inside of a procedure, you have names of parameters, you have names of variables, and you just get lost in these names. And unless you have some kind of a way to keep them straight, you'll run into conflicts between them. And you'll be using a name over here and say, well, you know, you can't use that name. You can't have the name of a constraint in a database, must be unique. However, the name of a field does not have to be unique. So if you name your constraints with the field, you will get them duplicates. So if I name my constraint P_ID and I have two of them, well, I'm having a problem. If I name it with the table name has to be unique. So if I use the table name in my constraint name.
I guess my question is, in the case of D, can we sort of treat that as like num or I, where we use it as many times as we want without worry?
The question is, with respect to D, with respect to this guy right here, this one that I have as the derived query. Okay, so here I'm giving it a name. This name is known only inside of this select statement. But with respect to D in general, as soon as I said this, create view, and I created it in the database, now the variable name, the identifier named D is,
Oh, that one, yeah, it actually creates a table. It's not, so,
well, it's actually, it's a table, it is a derived table. So D is stored now in the database, and if I tried to name a table D, it wouldn't take it.
that's where it creates conflicts.
Right. And it's best if you just keep them separate. That's why I'm a little, on things like constraints, I tend to name them something that's unique and something that gives me information. I would not name a view D. Now, if I were just making a derived table inside of a SQL statement, okay. Couple of things. Let's go back just to the derived table, and I don't know whether I did a good thing by getting off into that create view or not, but that's what happens here. You could create the view, you could select from the view, and then you could drop the view. Probably better to do it this way.
I'm guessing that view is useful when you need to invoke that same table multiple times.
Oh, absolutely. Yeah.
But in this case, if it's only a single use, then it's better to not have like something stored.
The question is, if it's only a single use, would it be better not to have something stored? I suspect that it is not particularly expensive to the database to create a view because it doesn't have to duplicate the data. The data aren't duplicated, just the SQL code is compiled and stored, so it probably runs fairly quickly compared to running a SQL query. So the view probably runs faster. I suspect that the overhead of storing it isn't that much. So in terms of creating it and then running it and then deleting it, probably you're better off just doing it this way, where it's just created right here on the fly, instead of creating the view, then selecting from the view, then dropping the view. I wouldn't do that.
So only when you need to
Right, if you're going to use it over and over again, it's good for security because it hides information. It's good for changing things and making the users think that things are different than they really are in the database. So you don't want to overload your users with having to know all about it. You can just create a view, and where they're used to select, instead of making them do a table join, I create a view. The view joins the tables and gives them just the information they need. Right, go ahead, Juana.
If you create table, as you like you are saying,
Okay, create a view.
and you are working on and you use it by time twice a month. Let's go and say we use it twice a month.
Okay.
Create a view.
To produce a report or something.
Yeah.
Okay.
And that information, it works. Let me ask you, I know it's a stupid question. So that information is getting updated every time that another information on the another table are getting updated.
The question is, do the information that the view produces, is it updated? Is it current content of the table on which the view is based? The answer is yes. There are some other nice things about a view. Under some conditions, I can insert, update, and delete into a view, and it will insert, update, and delete the underlying tables. Now, there's some conditions where I can't also. So depending on how it's made, if it just comes from one table, I can update it. Can I insert a row into a view? Will it be inserted into the table underneath it? Well, I'm going to leave that question for, I got to have something to do for the rest of the semester. I don't want to get too much into that. I suspect I usually have built in a little bit of time at the end of the semester where we can kind of bridge into some other ideas. And I usually might talk about views, and we get into these higher level stuff. Sometimes I'll talk about creating variables. One of the things you probably have noticed is missing from SQL, and it is indeed missing. You don't have a variable. Anybody notice that? I don't have a variable, and I can say I is an integer and let I equal 7 and go back to it later and find my 7 there. That is not in SQL. So if I want to store something and use it later in another query further on in SQL, I can't do that. This is where I step out of SQL into the surrounding language. There I have variables. Right now, this class is about SQL. I'm not going to burden you with a lot of other stuff. And yes, the views definitely are part of this class. So I'm not reaching out into the next one. Some students were griping at me last semester. Somebody says, oh, you spend too much time talking about the next class. Well, okay, so I won't. Until we get there, until the next class happens. Okay. Let's see. Where else can I put a subquery? So we have subqueries that can happen down in the subquery can come in the where line. Most frequently, they happen in the where line. Most frequently. They can happen in the from line. Okay. One other place they can happen is they can happen in the select line. Okay. And I don't know whether I'm going to go into that today or not. Derived table. What I select up here from the derived table has to be something that is returned by the derived table. Okay. In other words, the vendor name is selected. My max is selected. Vendor ID is, but I don't take it into up here, so it's not returned by this guy. So it is kept back and out of sight, out of mind. Same thing with a view. Well, this view, does not hide the vendor ID, but I would talk about how to do that. We're gonna have a whole chapter on views, so I don't want to get too lost in them right now. Let's go check and see what have I not done. Next. No, I guess that end of that is the derived tables. There's one other place that a subquery can be, and it can be on the select line. That's very rare. It's kind of esoteric. It's a little bit like the full outer join. Okay, so I'm going to get a lot fussier about people who aren't listening to my recordings, and so I'm going to try to make you listen to the recordings. And what I say on these recordings, you are responsible for. So I'll try to keep them to a minimum. I can do about an hour and 20 minutes, hour and a half. I don't know about your attention span, but I start seeing everybody's eyes roll up in their head, you know, at about an hour and a half. Okay, pretty much. Okay, well, I try not to bore you. So I'm going to wrap up. How we doing on the sound?
Pretty good.
Pretty good, he says. Are you guys out there in internet land? Golly, Brad, Daniel, Ivan.
Yep, doing good.
Okay.
You're good.
Ms. Gisela? You don't have to talk if you don't want to. Okay, we're going to wrap up there, and let's see. This particular one now is going to be in a quiz format. So this this guy, I'm going to go ahead and cancel the recording now. Okay, stopping the recording.